The last lab you did, the purpose of it was to find the velocity of a toy car as it moved along at a constant velocity on a horizontal surface. Well, today we're going to switch it up a little bit. The apparatus is going to be real similar, but the purpose of it is going to be different. Because we've been looking at acceleration, remember our Group B problems? Today we're going to try to find the acceleration of a toy car as it rolls down a slope. So what's the problem? Phrased in the form of a question, what is the acceleration of a cart as it accelerates down a slope? What is the acceleration of a cart as it accelerates down a slope? Or at least something like that. Doesn't have to be in those exact words. The last time we did a lab, I told you didn't need to worry about apparatus and materials. Well, today you're going to have to worry about that. The apparatus is up here in front of you in a photo right now. We're going to list out the materials, though, in words. What do you have to do when you hand this in? Well, you have to list it out in words. If you want to include a photo, that's okay too, but it's necessary to list it out in words. Now, if it's me, hey, I'd take a photo of it. I take a photo of it and insert it in a document. Why would I do that? Well, because it looks nice, but also because it's almost impossible for me to forget something if I'm looking at a photo of my apparatus. Does that make sense? It's less chance of you making a mistake when you're listing your materials if you have a photo in front of you. So what do we got here? Well, we've got our motion sensor. And our motion sensor is, of course, connected to our air link, just the same as it was last time. Those two are connected together. You've also got your iPhone, which is also connected to your AirLink, although it's not connected by a cable, it's connected via Bluetooth to the AirLink. This motion sensor, when turned on, will sense the motion of this Dynamics cart. This Dynamics cart that moves along this elevated track. This elevated track that's elevated because there's something underneath it, like a couple of books or a binder or something to cause a bit of a slope. That's your apparatus. That's your materials. What comes next? Well, it's going to be procedure. That's what you have to do next. Again, for the last lab, you didn't have to do a procedure. For this one, you do. What should the procedure look like? Well, the first thing you should do is remember that you have to number the steps. 1, 2, 3, 4, 5. Don't write it in a paragraph form. Number the steps. What do you got to do here? Well, first thing you got to do is connect the motion sensor with the AirLink. Then you got to connect the AirLink with your iPhone. You don't have to give me the details as to how you do that. Just say connect the motion sensor to the AirLink, connect the AirLink to the iPhone. Okay? Set up the motion sensor at the end of the track. Elevate the track by putting some books underneath it, or what the binder or whatever it is underneath it. Put the cart on the track. Push start on the app on your iPhone and let the cart go. Make sense? That's it. That's your procedure. That's what you're doing. Now, what are you going to do with all that stuff? Well, you're going to analyze the data in a way that I'm going to show you in a couple minutes, but that's not part of your procedure. Your procedure is what you do in the lab. You connected this, you connected that, you elevated the track, you press start, you allowed the cart to go down the elevated track, and then you press stop, and then you were done. You were done collecting data. What's your data going to look like? Well, you're going to have, just like last time, when you import this data into Google Sheets, a dozen or so columns of data, including time, position, velocity, acceleration, sound intensity, and all kinds of different stuff. You're going to delete all the columns except for 3. Last time you deleted them all except for 2. We kept time and position. This time we're keeping time, position, and velocity. So you should have 3 columns: time, position, and velocity. None of these are calculations. These are all things that your iPhone is going to record and send to you when you email the data. Then we have to do our analysis, which includes, first of all, 2 graphs. The 2 graphs should be position versus time and velocity versus time. Your position time graph should look something like this. Okay? Your velocity time graph should look something like this. Now, that's a perfect representation of what we should see, right? It's not going to be a perfectly curved line like this or a perfectly straight line like this, but it should be relatively close. You should clearly see the trend of a curved line and a straight line. Then you got to answer a couple questions. Number one, describe the motion of the object using the position time graph, referencing the shape of the graph. So you're going to look at this and say, oh, okay, I know that because of the shape of that graph, it's going at a constant velocity. Or I know that because of the increasing slope, the curving upwards, it's going to be acceleration. Or I know that because of the curving upwards, it's going to be deceleration, whatever the case may be. Just tell me, because of the shape of the graph, you know that the motion of this cart as it goes down the slope is what? The second question says, what is the acceleration of the velocity time graph using the velocity time graph? So using this graph, what is the acceleration? Well, when it says show your work, I don't mean show a whole bunch of handwritten work on this. I mean, just show me that you've entered the right thing into Google Sheets to give you the acceleration. If you display the equation, which is going to be in the form of y equals mx plus b, something like this, let's say. Now, your numbers are going to be completely different, of course. But if you display that equation, that's enough work. That's showing your work sufficiently. The acceleration of the object would be this value right here. It's the slope of the graph. So plot the graph, get a line of best fit. For this one, you want a line of best fit. For this one, you don't, because it's curving, right? Don't draw a straight line for a curved line graph. Draw a straight line for a straight line graph. Get the slope with the equation of that graph, and then answer question number 2. Your conclusion? Remember what the problem was? What's the acceleration of this cart as it accelerates down the track? The acceleration of this cart is blank meters per second squared. This is known because, and I'll leave you with that. How do you know that that's the acceleration of the graph? We pretty much already talked about that, right? And then finally, of course, your sources of error. They list 2 or 3 really good sources of error, things that could have been better, involving your procedure, materials, and so on, not human error. And then give me 2 or 3 good suggestions for improvement for those. So what do you got to hand in for this one? We got our problem, which I gave you. We've got our materials, which I gave you, although you might forget them. So pay attention and write them down as you're going through the lab so you don't forget them. Take a picture, whatever. You need your procedure, which I essentially gave you, although you're going to write that down in your own words. You need your data, which is your table right here. You need your analysis, which is your 2 graphs and the answers to the 2 questions, your conclusion, and your sources of error. What's different between this one and the last one? You got to do a little bit more because there's a couple graphs instead of just one. But in addition to that, you've got to do materials and procedure, which you didn't have to do last time. All right?